Graham's law of effusion. Fusion's kind of an interesting word. It is the escape of gas molecules through a tiny hole into an evacuated space. The rate of effusion for helium is greater than that for nitrogen because the mass of helium is less than that for nitrogen. Helium particles travel faster, and this explains why a helium balloon will deflate faster. So we have here two balloons, the same volume. One is nitrogen, one is helium. After 48 hours, look at this, and the small hole is probably, a leak right here where you tied it off. After 48 hours, we find out that the helium balloon was smaller. Thus, the rate of effusion for helium is greater than that for nitrogen. Graham's law of effusion states that the relative rates at which two gases will effuse is inversely proportional to the square root of their molar masses. Kind of did that a couple slides ago where we used the kinetic energy equation. So again, the greater the velocity, the quicker they effuse. How much faster would we expect hydrogen gas to move or effuse relative to nitrogen gas? So here's our molar mass of nitrogen gas. We get that off the periodic table. The molar mass of hydrogen. So give that a shot before we move this for the answer. So feel free to pause the video. And come on back. Let's see what we have. We have our Graham's law equation. V1 over V2 is the square root of M2 over M1. So we put in the molar masses. And make sure you put them in the right place, right? Here's your nitrogen, and here's nitrogen again. They kind of crisscross there. We divide that out, get the square root of 14, which is 3.74. So hydrogen will travel 3.74 times faster than nitrogen, or the relative rates of effusion would be 3.74 relative to 1.